So this question here, we have two different carts with different masses. They're connected by a spring, so they're compressed together, and then they're released. So this is a standard explosion, which are best served by momentum. And so what we know about the momentum in these cases, rather than trying to figure out the answer, is just what do we know? Well, we know they are going to accelerate backwards. And if we know that if they are equal mass, if this is m and this is m, and they explode, they will have the same velocity. If we know that if this one is m and this one is 2m, we know this one is going to have twice the velocity of this one. And if this one is m and this one is 4m, we know that this one will have 4 times the velocity of that one. And so those are just the things we know about an exploding case. So after the carts are released, the cart of mass m moves with a velocity v. So the law of conservation of momentum applies. We have p0 equals 0. And afterward, we know the momentum must be equal to 0. So we have a delta p on this side, and we have a delta p on the other side. And for law of conservation of momentum to hold, those changes in momentum must be equal and opposite. The change in momentum on this side must be equal and opposite to that side. Well, if this change in momentum, the one on the right, is mv, then the one on the other side must be negative mv. It looks like choice B. Now, if we had done this differently and we said that this one is delta P, the left one is delta P, and the right one is the opposite, well, we would have negative mv, and the other side would be negative mv as well. So it would still give us the answer, the same answer, no matter which way we assign the positive and the negative, because the other side is equal and opposite. Now, how do we know that the other answers are wrong? Let's go through those. We definitely want to make sure we do that. What this one says is that it has exactly the same momentum as the other. Momentum is a vector quantity. If I have mv plus mv, that's going to give me 2mv. Well, the initial momentum should be equal to the final momentum, and the initial momentum was 0. Well, that doesn't equal 0. It must be opposite direction. Now, in this case, m and v are not equal. We are told that they have different masses, so we expect them to have different velocities. So if the one to the right has a momentum of mv, and the other one has a rate of big MV, then that would mean that big M and little m must be the same for that to be true, which is not the case. And it has nothing to do with negative or positive. They would be the same size. And so that's why the answer is choice B. The trick in this question is us trying to find out actually what the momentum of this other cart is in terms of the big M. That is the mistake that's easy, that could really get you stuck in this question. It just comes back to the definition of the law of conservation of momentum and seeing that the change in momentum of both of those are equal and opposite.